To look at the settings of the virtual machine itself, I'm going to right click my SVR2 and I'm going to go to settings. Now we have two sections here. One is hardware and the other is management. To look at the hardware section first, if I wanted to add hardware to my virtual machine, the top option is just to do that, add hardware. So here I have a SCSI controller. If I were to go to add, I could add a hard drive, a DVD drive, I could add a shared drive. Now, I don't actually want to do that, so I'm going to click remove because it did add this SCSI controller in here. But if I go back to add hardware, you could add a network adapter. So if you wanted a second NIC in your machine, that's an option. You could add a remote FX 3D video adapter. Now, this is no longer supported. So you could use this in Windows Server 2016, but it's not an option in Windows Server 2019. For whatever reason, Microsoft simply did not remove it from the interface. So it still shows up here, but it's always going to be grayed out and you can never click add if you select it. If you are connecting to some type of storage area network on the back end, you could add a fiber channel SAN, so that would be an option. So that's the hardware you can add. Drives, NIC adapters, fiber channel adapters. Now, if we go to firmware, this is very much like going to the BIOS or firmware on your personal computer. You can change the boot order here. So you'll see for this virtual machine, it is set to boot from the network adapter now, which is actually not connected. Then it is set to boot from the hard drive, which has no operating system on it. Then it's set to boot from the DVD drive. Now, since I added this DVD drive last, it actually moved it to the bottom of the list. So what we need to do before we can actually boot from that ISO file, and you'll see the ISO file here is actually inserted, I need to move it up. So I'm going to move it to number 1 because I know that's what I intend to actually boot from. Now, if you had added the ISO file while you were creating the virtual machine, the DVD drive would have already been at the top of the list and it would have been a non-issue. But I'm just going to move that up and I'm going to be sure I click apply just to make sure that actually does take effect there. If we don't do that and leave it at the bottom, when we boot, it's going to boot past the network adapter up to the hard drive and then it's going to say no operating system found and you'd have to troubleshoot as to why it's not booting from the ISO file. But if it's not booting from the ISO file, the only two reasons, your boot order is incorrect, or you simply didn't actually attach the ISO file. Those are the only two common reasons it would fail to boot from that file. If I go to security, Secure Boot is already enabled. And Secure Boot, they give us a short description. This will help prevent unauthorized code from running at boot time. So if you have malware or viruses on your machine that affect boot files, Secure Boot will make sure they can't affect those files. Your physical computers all do that now as well. Have for quite some time. I can also enable this Trusted Platform module, which is always called a TPM. Now to do this, you need to have a TPM in your computer, which is actually a type of microchip in your computer that can store these encryption keys. If we were to enable that, you could actually encrypt your virtual machine migration traffic. You could have the hard drives encrypted of the virtual machine itself, but you just need a TPM chip in the physical computer. When you purchase a computer or server, that's always an option if you want to have a TPM included or not. On the client side, like Windows 10 and earlier operating systems, even going back to Windows 7, you will hear of BitLocker, which is Microsoft's hard drive encryption. Now, you can also use BitLocker on Windows Server, but BitLocker can also use a TPM to store the encryption key for your hard drives. That capability just carries over to Hyper-V. The last option is Enable Shielding. This Enable Shielding actually separates access for the virtual machine from the host it's on. Now, what I mean by that, I'm going to click Enable Shielding and OK. Now, if I go to this virtual machine and connect to it, I can start it up, but it would not actually show me the interface if I were to do that. The reason, when I'm in Hyper-V, you may have storage in Hyper-V, so I may have a need for storage administrators to log into this host. You may have a need for network administrators to log in, and maybe network administrators will work with virtual switches. So I may have different levels of administrators that need to log into this machine. I, for added security, can say, yeah, you can log in, network administrators, and you can manage your virtual switches. You could even possibly go through settings of a virtual machine and manage like network adapter connections and things like that here. But what I don't want you to do is to be able to click any of these machines and directly connect to it and bring up the login screen. So you could simply separate access to the virtual machine from the host. Now that I have shielding enabled for this, I'm going to click Start. And notice this is all we get. It says if the connection cannot be established, use a network-based management tool like Remote Desktop Connection, Windows Remote Management, or SSH. This is going to just stay on this screen. It's not going to pass this and bring up the login screen. Now, one thing to be concerned about, some changes Microsoft made to this. You'll see here it says waiting for enhanced session virtual machine connection to be available. I'm going to close this screen here. But if I right-click my host and go to Hyper-V settings at the host level, there is this enhanced session mode. If this is checked, once you install the operating system, it will actually bypass that shielding and it'll still bring up the virtual machine once the operating system is installed. So you would need to deselect this enhanced session mode. Then when anyone connects to any of these virtual machines, all they will ever see is this screen here. So you would have to remote desktop to it if you wanted to connect to it, to manage it for any reason. Just connect from a remote machine. You won't be able to just simply right-click connect on the host itself. But I'm going to just turn that off. So I'll turn off. And I'm going to go back to settings, and I'm going to turn off that shielding. Now, when I enable shielding, it also selected these encryption options for TPM. I'm going to turn that off as well, and we'll click Apply. Now, the other settings are fairly straightforward. I can go to memory, and I can specify the startup RAM. This 2048 megabytes is what I selected when I created the virtual machine. So if you wanted to adjust that, you can adjust that now. The dynamic memory, when that's enabled, this is the minimum, this is the maximum, and you can change either of those numbers if you wanted to. Well, there's no point to change the minimum. But if you wanted to change the maximum, you could increase, decrease if you wanted to. But your virtual machine, as long as that dynamic memory is enabled. But now your virtual machine will simply scale up and down as it needs more or less memory, as long as you leave this dynamic memory checked here. We can also have memory stored in a buffer. Now, the point of this, let's say this is a database server. It's like a Microsoft SQL virtual machine. If that's true, it may get a burst of traffic and it may need a lot of additional memory very rapidly. So what we can do is tell the host, we want you to reserve a certain amount of memory in a buffer for this virtual machine. So if it needs it, it'll automatically allocate it. So essentially reserved memory, rapidly available to this virtual machine. Now the other, memory weight. When you create your virtual machines, well, if you enable dynamic memory, all the virtual machines will go up to this number. Well, I have 3 virtual machines right now. I know I don't have enough RAM in this host to allocate the maximum amount of RAM here to all 3 virtual machines. Simply not possible. So that begs the question, what happens when your virtual machines all start consuming more memory and they begin to exceed what's available in the host? Well, that's where this memory weight comes in. With the memory weight, I can say if there is not enough memory for all of these virtual machines, which one should have preference? Let's say RTS serve 2. I want to give this preference. If all my virtual machines start consuming more memory, then you can simply drag this over and it gives you a higher preference. That drives me crazy that they don't have numbers under these little, it's kind of hard to see, but it's like these little tick marks, I call them. But 1, 2, 3, 4, it defaults to 5 in the middle, and I just moved it to 6. So if there was memory contention, this virtual machine would now get it because the other virtual machines would all be set at a level of 5. So just a memory prioritization is all that is. Now for the processor, I could allocate virtual processors. So right now I have 1. If I wanted to allocate 2, 3, 4, what number of virtual processors I wanted, I could simply allocate that to my virtual machine. Now I'm just going to allocate just one because we're not running any processor intensive applications on these. Now I have my hard drive. No, we're not really doing anything with that. That was just defined when we created the virtual machine itself. I have my DVD drive we added, and I did add the image file to the DVD drive. We just browsed out to that ISO. The network adapter, that is still not connected. We will come back after we create a virtual switch and we will connect that virtual machine to our virtual switch. Now there is a virtual switch in the list. If you remember early in the course, we had to walk through installing the operating system and activating the operating system, and I did create a virtual switch named vSwitch. I could connect this to that vSwitch, but I'm going to create a completely separate switch for that later, so we'll revisit that in a moment. But that is everything under our hardware. Under the management section, I have just the name of the virtual machine. Now that is like the name that you're seeing here. That is not the computer name. Computer name has to be defined once you install the operating system and log in. You can set the computer name to whatever you want. Does not have to be the same as the virtual machine name. Although for ease of simplicity, it almost always is the same name. If not, it can just prove to be confusing. Now, these integration services, I am in the settings of a single virtual machine. These integration services let me decide what services from the virtual machine should be integrated with the host. Now, some of these you certainly want. The operating system shutdown. With this, when I shut down the host, I can have action taken against this virtual machine. Because what I don't want to do, if I need to restart the host machine here, I don't want to have to go shut down each of these virtual machines or save the state of each virtual machine before I shut down the host. So the operating system shutdown here actually integrates with this automatic stop action. So as long as that's checked, operating system shutdown, this automatic stop action actually dictates what happens when you shut the host down. So by default, it will save the virtual machine state. That simply means every window you have open, every application you have open, it's actually going to save exactly that view, those components that are running in memory, all that's going to be saved. When you start the virtual machine, we can simply have it reload back to that same exact point. So that's always the default, save the virtual machine state. You could turn off the virtual machine. Never would you choose that as an option. It will never be the default. You would choose shutdown if you truly wanted this to power off. This will send a shutdown signal to the virtual machine as if you had clicked start shutdown, and it completely powers the virtual machine down. Turn off is the equivalent of pulling the power plug on a computer. It is just a sudden loss of power, and it can actually corrupt the operating system. It makes no sense that Microsoft has this option here. If you go through the docs.microsoft.com site, they'll tell you this should never be the default option you set. Yet they make it available for you anyway, but no, we will not choose that. Truly should not be in the view. So either you save the state, which is the default, or you do a graceful shutdown. Now, if we go back to the integration services, for those two things to actually work, the shut down the operating system, save the state, you do need to have the operating system shutdown selected here, and it is selected by default. Now, I can also have time synchronized. Time synchronization simply means this virtual machine will synchronize time from the host. So whatever time the host is in, VM simply clones that time. The data exchange. This is sometimes known as a Hyper-V key value pair exchange as well, the data exchange itself. This enables metadata between the virtual machine and the host to be copied back and forth. So not something we really actually manage. It is just enabled by default, and we will leave it enabled. It's mainly exchanging configuration information within the virtual machine back to the host itself. Now, we also have a heartbeat. This can be used to monitor the state of the operating system within the VM and verify that it actually booted correctly. An example of how the heartbeat could be used, I'm going to pull up PowerShell for a moment, And in PowerShell, I'm going to run this get-vm -vm name, and I'm going to choose RTS SVR2. Now, we know that VM is actually not running. I'm just going to pipe, and I'm going to say select name, state, and status. And I'm just going to run that. You'll see it says RTS serve 2. The state is off, but it says operating normally. So no configuration issues have been detected related to that virtual machine. If it was on, it would actually tell us the state is actually running and it's operating normally. So this is a quick way from the host that you could just connect to your virtual machines and you could verify that your virtual machines are actually running correctly. Now, if I hit the up arrow, and I'm just going to scroll back over, and I'm just going to put comma RTS SVR1 comma RTS-DC1. So same command, get-vm -vm name, all 3 VMs, then the pipe symbol, select name, state, status. And it gives me that for all 3 of my virtual machines. So I can see that all are either in a save state or off. If I go back and run that again, this time I'm going to arrow over and I'm just going to type an asterisk and I'm going to run that command. And it gives you every virtual machine. Like if I know I want every virtual machine, well, it's a waste of typing to type RTS serve 2, serve 1, and DC1 if you know you want all of them. So you could simply run this command and view that status. Pretty fascinating. Now I'm going to switch back to the virtual machine settings. The next on the list is the backup. It says volume shadow copy. This service allows you to back up data and applications of the running virtual machine and does not disrupt the virtual machine while it's actually backed up. So you can simply have these shadow copies is what they're usually called. You can just have these taken as the virtual machine is actually running. Now, all of these are selected by default except for guest services. This enables you to copy files from the Hyper-V host to a running virtual machine and vice versa. You don't need a network connection to actually do that. So I don't have to copy through the network. You can just directly copy from host to the virtual machine with the guest services. Now, the next option on the list is checkpoints. We come back to that in one moment because we're going to look at that by itself. So if we skip over that for now and go to this smart paging file, all operating systems write to a page file. So when you start your computer, it loads a lot of things into memory. Some of the things it loads in the memory are then written to the hard drive in a file named pagefile.sys. So if you've heard the term page file, swap file, virtual memory, they're all related to the same thing. Smart paging file is simply the location this virtual machine will really use for virtual memory. So things will be taken out of memory and written to that location. This is used during startup. So it helps virtual machines start faster. Rarely is that ever changed. Now, we looked at the automatic stop action. Save or shut down were our valid options. Turn off, we said you would not choose. Right above that is the automatic start action. So in this previous example we talked about, when I shut down the host, the virtual machine goes to a save state. Well, what happens when you restart the host? That is automatic start action. The automatic start action will default to automatically start if it was running when the service stopped. So what that means for me, when the host gets shut down, the VM goes to a save state. When the host gets powered back on, the VM automatically powers back on. So if I know everything goes to a save state, then it auto starts. You could reboot the host and once the host powers back up, users could connect to shared folders on your virtual machines. If you have domain controllers, they would start authenticating users again. It would be as if you had never shut down. Now, the other options, do nothing. That means this virtual machine I'm on right now would be powered off and I would manually have to go to the virtual machine and start it. The last option, always start this virtual machine automatically. Simply means it does not matter if the virtual machine was running or not when the host was shut down. It's going to always start up when you start the host. You can also build in a startup delay. Now, it's a few reasons to do this. They say to reduce resource contention between virtual machines. That's one of really two reasons. If you have, say, 20 virtual machines on a host, and you reboot the host, if all 20 virtual machines try to start at exactly the same moment, that's going to degrade performance, and it's going to take a while for all of those virtual machines to start. So one reason you build in a delay is just to say, I want this virtual machine to start now, and I want this one to start, 60 seconds later. And you just kind of build in a delay. The other reason you would choose to build in a delay, if you have virtual machines that replicate with each other, maybe you have two file servers on this, and they replicate files from one to another. Anytime you have a machine that replicates, you traditionally have like a primary that's actually looked to from the replica. So in that instance, I may have these machines that replicate some type of data, configuration settings, or something like that. I may always want to make sure that machine 1 starts, then machine 2 starts, and compares itself against machine 1 to see if it's current through replication. So that would be the other reason. Just based on some applications or data you run, there may be a preference as to which machine starts first. But I'm going to leave this on the default. Automatically start if it was running when the service stopped. Now, we didn't really make any changes to any of these. So I'm going to click Cancel. And that's our look at the settings in an individual virtual machine.